Hi everyone, this is Miss Afric here, and we're going to continue talking about graphing square root and cube root functions, but we're going to add one extra new piece, and that's identifying the domain and range. Do you remember hearing those words before in Algebra 1 maybe? If not, we're going to go through it, so don't worry. That's just our big focus for today, is understanding how to identify the domain and range. Okay, so the new vocabulary for some of us maybe would be, first of all, domain. And the domain of a relation is the set of all x values for the function. And another word you can use to describe domain is the input. Alright, so it's what we're putting into our function. And domain, that always has to do with our x values. Alright, another new vocab would be the range. And the range of a relation is the set of all y values for the function. Alright, another word you can use to describe the range is the output. So the range represents the numbers we can get out of the function. Alright, and then the last piece, which we've been using for quite a while, is the word function. But we haven't actually talked about what a function is defined as. Alright, so any equation or table or graph is known as a relation. And we would qualify and say a relation is a function if each element of the input maps to exactly one element of the output. So for example, every x, because x is input, can only have one y, because y is an output. Alright, the best example to try and remember that one is I like to think of like people and birthdays. So every person can only have one birthday, but a birthday can have multiple people on it. Right? So as long as every person has only one birthday that it maps to, that means it's a function. If a person has more than one birthday, that wouldn't make sense, right? So that's why it's not a function. Alright, we're going to use some of that new vocab to help us with a few of these problems. So let's take a look. For 1, 2, and 3, it says identify the type of relation that's pictured, its domain, and its range. So type of relation, we have a few different types of functions that we've learned about this year, I suppose. So let me just list a few of them for you. Alright, there's a constant function, and that means it's only on one value, one output. Alright, we could have a linear function, so that's y equals mx plus b. We could have a quadratic, quadratic is x squared. We could have a cubic, cubic is x to the third. And then the new ones we learned yesterday would be the square root and cube roots. So square root and cube root. Alright, we've learned a few other ones, but those are the main ones we're going to see so far. Alright, so for number 1, it says y equals -7. So when there's no x term even, that means there's only one output value, so we call that a constant function. Now the harder part, domain and range. So remember, domain are the possible x values on our function. So if I look at this graph, I can see that I could plug in any x value into this function. I'd still get the same y value out. The fact that I would be able to plug in any x value means we would say the domain is all reals. Alright, in case you forget what that means, that's all real numbers. Right, because I can plug in any x into that function. For the range, though, range are the y values. There's only one y value that I'm going to get out of this function because it always equals -7. So my range would simply be y equals -7. There's not going to be too many times where our range is a single value, but in a constant function, that's just what happens. Alright, number 2. Number 2 is y equals x minus 2 to the 1/3. Do we remember what the 1/3 means? Hopefully, that's like a cube root. Alright, so this is going to be a cube root function. And for a cube root, let's take a look at the equation and the graph, right? Are there any x values that I couldn't plug in here? No, it looks like it covers all x values on the graph, right? And I can't think of any reason why I couldn't have any type of x value under a cubed root. So that means for my domain, it would be all reals. Alright, for my range, I'll ask the same kind of question, and one little hint is see how our graph is continuing to go up and down right, in both directions, that means eventually, it may take a while, but eventually it's going to hit every single y value, all right? And if we think about this, right, when we take the cube root of a number, we could get a positive or negative answer, so that's going to tell us that our range is all real numbers as well. All right, cube root will always have all real for domain and range, because there's no limitations on an odd root. Now for number 3, it's a different story. All right, x plus 4 to the 1/2 minus 1. Remember, 1/2, that's a square root. All right, square roots are different, or rather, even roots are different. Because when we have even roots, remember, you can't have a negative number underneath an even root. Otherwise, we would have imaginary answers. So when you have an even root, remember that you can have no negative number under it. And write that down because we tend to forget that a lot. All right? So when I have an even root, like a square root, I can have no negative number underneath it. Now, first of all, sorry, I should have started with this. This is a square root function. But now when it comes to domain, I have to keep in mind that the part that's underneath my square root, which is this x plus 4 part, cannot be negative. Well, if it can't be negative, the way we would write that is we would say x plus 4 has to be greater than or equal to 0. That tells us that it has to be 0 or positive. All right, so if I solve that inequality real quick, I get x is greater than or equal to -4. So for my domain, I would say all reals where x is greater than or equal to -4. Hard to fit in there, I know, but that's what we've got. All right, and you can see based on the graph that that makes sense. There's -4, it's going to the right, so it's got to be bigger than -4. All right, for my range, the range of a square root, well, since we can't have negatives underneath a square root, we're never going to have negatives outside of a square root. All right, so this complete function should never be negative. And if you look at our graph, that's the easiest way for range. You can see that the smallest y value is this -1 right here, and then it starts going up. So for my range, I would say it's all reals where y has to be greater than or equal to -1. So you can use the equation for domain or the graph, but for range it's a lot easier to use the graph. Okay? Alright, let's try a few more. For numbers 4 and 5, just determine the domain and range. So for number 4, I have a table. Tables are interesting because tables don't represent every point, it's only the points listed. So my domain for a table would just be my x values listed. So these 4 right here. And I like to make sure they're in order, so smallest to biggest, which they already are. And these brackets I'm putting around it just means like the set of these numbers. Okay? Same idea for range. Range are the y's, so I would look at my y values and do the same thing. It's just the set of those specific y values. So tables, you always just look at the numbers you're given. All right, number 5. Number 5, we have an equation. So y equals x plus 5 to the 1/2 minus 2. So once again, that's a square root. So if you want, you could also rewrite it as the square root of x plus 5 minus 2. All right, if that'll help. So when it comes to the domain, once again, you can think of it as whatever's underneath an even root has to be positive. So that means it needs to be greater than or equal to 0. So if I solve that, x would have to be greater than or equal to -5. So I would say my domain is all reals. We always start with that just in case for an equation. But then x has to be greater than or equal to -5. Now remember before I said the range, it's easiest to look at the graph. Well, you could type this into your calculator and get the graph, right? Or you could do it by hand since that's what we've been talking about. But the other way to do it, just using the equation, is to look at this number out here. Okay, that's our shift, right? Our shift in this case down 2, if you remember that. So that's what's going to impact our range for these square root functions. This would be just a normal square root function with a couple shifts. And since it's shifting down 2, that's where the y values start. So if my y values start at -2, that means they would have to be -2 or bigger. So the way we would say that is all reals where y has to be greater than or equal to -2. So you can kind of see that these are just based on our shifts inside, right? So that does help. Alright, let's try a few on the back. So for these, it says graph the following function and determine the domain and range. You are going to need your calculator, so go ahead and pull that out now. Alright, so here's my calculator. Got it all ready. Hopefully you do too. Make sure you're typing this stuff in right. Alright, so for number 6, it says y equals the square root of x minus 2. And we want to decide on the domain and range. So now you can do the domain and range before you graph or after, whichever is easiest for you. Alright, so you make that call. As for the domain, that one's usually with the square root at least, pretty easy to start with. Alright, remember this is a square root, so that's an even root. And in even roots, whatever's under my even root has to be greater than or equal to 0. So in this case, that's just x has to be greater than or equal to 0, because nothing's underneath there with it. Alright, so what's underneath has to be greater than or equal to 0. Just keep that in mind. As for the range, we look at our outside number. Alright, so for my outside number, that's shifting down 2, so y would have to be greater than or equal to negative 2. Alright, now in order to graph, remember, we're going to use our table, x and y, and that's where our calculator is going to come in. So I'm going to type this function into my calculator. Square root of x, move over so I'm not underneath the radical anymore, minus 2. And then I'll go straight to my table. Now remember, for these you have to make sure you know where to start. So if I look at this equation, my horizontal shift underneath, there is nothing. So that means my starting point is 0 for the x's. And then my vertical shift on the outside is negative 2. So that's my starting y value. So for this table, I'm going to start with 0, negative 2. And lucky for me, that's where I'm starting here. If you ever want to double check that you did that right, just scroll up. You'll start seeing those errors, and that's how you know you're starting at the right point. Okay, so I'm going to pick some nice points here. Let's see, 1, negative 1. If I keep scrolling, I got 4, 0. And that should do it. So what I'm going to go ahead and do is plot my points, and then draw my graph. Alright, and after I finish drawing, I always go back and double check my domain and range, because sometimes I miss something and it makes me mess up my answers for that. So domain means x's. So for my x's, I'm starting at 0 on the x-axis and going to the right. So x is greater than or equal to 0 makes sense. And for my y's, I'm starting at negative 2 and going up. So y is greater than or equal to negative 2 makes sense. So these check out, so I'm feeling good. Alright? Okay. You can try this one on your own. Right? See if you can get that one. Or we can do it in class. So if you get stuck, we'll cover it in class also. Alright? But if you feel like you could try it, go ahead. Just be really cautious about this negative. Alright? Just a little warning when it comes to domain and range. Alright, and then we're going to go ahead and let's do number 9 here. Okay? So we'll save this one for class also. So in number 9, now this one, we have a cubed root, right? So if I were to rewrite this, it would be like y equals negative, and then a cubed root of x minus 4. Odd roots are nice because odd roots, the domain and range, are always all reals. There's no restrictions on an odd root. Okay, so if I want to type this in my calculator, I'm going to go to the y equals, clear that out, type it in exactly the way I see it, negative x caret. Now be careful, if you have one of the older systems, make sure you're using parentheses here. Get out of there, and then minus 4. Okay, go into my table in order to get this graph. Now remember, for these functions, we don't have a starting point, we have a middle point. Alright, so the middle point, sometimes it's easier to see it on this one. There's no transformation in the x, and there's a down 4 shift in the y. So my center point would be 0, negative 4. And then we would use our calculator for the rest. Alright, now I'm running out of time, so I'm not going to use my calculator. I'm just going to go ahead and fill these in for you. But you would use your calculator, alright? We would plot these points, and then we would connect them, and there's our graph. Alright? Don't forget to double check your domain and range also. Now, if you have any questions at all, write them down or try rewatching because sometimes that can help a little bit. Otherwise, ask away in class and we'll see you then.